Question number 11. An object moving with a uniform acceleration of 10 meters per square second has a velocity of 10 meters per second. After how long does it take? How long does its velocity double? Right. So here u it is 100. Now it is 200, double. Right. Acceleration it is 10. It is so time taken. So different 100, right? Here 10, so time taken 10 seconds. Answer 2. And question number 12. A, B, C, D, E, F is the center of equilateral hexagon when 5 forces A, B, A, C, A, D, A, E and A, F act. Their resultant sum of resultant of vectors is equal to. Okay, now here you can see all the vectors are start from A, right? So but all are in the homogeneous, right? So we know what are the requirements to what are the requirements should be fulfilled to become two vectors to be equal. So requirements that should be needed to become equal. First one, we know it should be homogeneous, right? Both, suppose there is a two vectors called suppose AB, other one PQ, right? So AB should be homogeneous, both, right? Suppose AB is a force, PQ should be a force, right? So it calls a homogeneous. The magnitude should be equal in both vectors, right? Then directions should be same, AB and PQ, and both vectors should be parallel to each other. If those four conditions are fulfilled, you can say AB vector is equal to PQ vector, right? So here, based on the theory, we can consider CD is equal to the AF, right? So we can bring that AF to CD, right? Okay, because there's no path to move A to F and F to E or any other places, right? But if we parallel to here, right, there's a path. So here, based on the theory, the AB vector is equal to ED. So here I can bring to here, right? Now you can see there are three paths can be moved from starting A, right? So here if we start A, F, F, D, sorry, A, E, E, D, the resultant it is A, D, right? Here initial and final point, initial to final. Then A to C, C to D, again resultant initial to final AD, right? So there's a single vector A to D, so 3 A D. Answer 4. Right, question number 13. When an equation of F equal 2phi r1 plus 2phi r2 k, F is a force, r1 and r2 are radius, the dimension of k is. Question number 13. When the equation of F equal 2phi r1 plus 2phi r2 into k, F is a force, r1 and r2 are radius, the dimension of k is. Right. If this equation is a correct equation, we know the dimension of each terms, right? Dimensions of each terms should be equal. So if we comparing these two, right, here constant, so k should be F over r1. F it is mlt minus 2, R is L, so mt minus 2. Answer 1. Question number 14. The shapes of displacement time graph of 3 objects are shown in the figure. A. All 3 objects move in the same direction. B is always behind C. C. The acceleration of C is maximum. True of these. Right. Here, first statement, all 3 objects move in the same direction. Right. You can see the direction means the velocity. Right. Here, all are move in the positive side of displacement. Right, because it marks the positive region. Right. But by the gradient, the sign of the gradient represents the which direction it moves. Right. So here B and C it make acute angle with the positive side of x. Right. So B and C move same direction, but A it makes obtuse angle, so opposite direction. So A statement is wrong. In B is always behind C. Right. So it is not. Right. So here in here C at the initial, right, C it is behind the B. Right. After few seconds, right, C move with higher velocity. So after few seconds C pass the B. Right. So here it is not correct. In C, the acceleration of the C is maximum. Now all the 3 objects graphs are represent the uniform velocities. Right. So uniform velocity. So velocity is uniform means there is no change in velocity. So there is no change in velocity means acceleration is 0. There is no acceleration. So C also wrong. So answer not all. Right. Question number 15. 2 equal forces of 2 Newton each are applied to an object. Which situation shows where the sum of the 2 forces is approximately 1 Newton can be? Right. Sum of 2. Right. So here if you consider the resultant or sum for the first one, it is equal and opposite. So resultant it is 0. So here it is perpendicular. Right. The resultant you can get using Pythagoras theory, it should be 2 root 2 Newton. Right. So here this one it is like 30 or something, suppose it is 60. Right. So here it is if it is 60, 2 into 2 cos 30. Right. So it is 2 root 3. It is greater than 2 also. Now here like it is 120. Right. As a scale, right, if we consider about the scale, right, if it is 120 mean here 2 Newton, here it should be 60, here also 2 Newton, so the resultant to here also 2 Newton, like equilateral triangle. Right. So here it is like a 150. So here if we draw here 2 Newton, here now 150 mean here it is 30. Now is here resultant is given by this way. So it is like less than 2 Newton. Right. The length, this according to the scale, you can see it shows like less than 2 Newton, the length of resultant side. So it can be resultant to the 1 Newton. So answer should be 5. Right. So we can remove 1, 2, 3, right, without any doubt. Only the doubt between here and here. Right. It is better in this question it is mentioned about the angle. Right. But you can see if you look at the diagram closely, right, the fifth one the angle is look like the greater than the fourth one. Right. So maybe the approximately closest to the fifth one to the 1 Newton, right? So most suitable one, it is fifth answer.